All right. So good morning, everyone. So hopefully you're in the right place. This is talk on the virus total intelligence and with the use case of tracking malicious actors through maldoc campaigns. My name is Wyatt Roersma, and for those of you that don't know me, I research for fun, and I also do it for a job. Happen to be lucky enough to do both there. And I'm well known for my work with volatility. If you're not familiar with volatility, it's just a memory forensics framework. My most popular research in volatility was the research I did in Hyper-V memory forensics. And I've also been responsible for the last couple of years of the GrrCON Digital Forensics Challenge. Amongst a number of other things, I also work at Target, and I do some other random things on the side for fun. So first question is why am I here? Why am I talking? And why should you care? So basically, there is an internal need for us to develop our own intelligence gathering, whether it be within our company or your company as well, big or small. Huge waves of phishing campaigns have been very common throughout the years and have been at least a topic of highlight for us recently, just kind of tracking those and trying to learn how to deal with that. So we're going to go from how do we detect them and how do we go and pivot on that information to find other related campaigns or maybe something you might be missing, and deploying that into like detection and potentially blocking things or alerting on it depending on what capabilities you have. And then, I want to make Intel valuable, and I don't want to just make it valuable in a sense of like resale, but like for a small company that doesn't have the money to go and buy very expensive Intel from the various Intel vendors. Because if you want good Intel, it's going to cost you a lot of money, and most places really don't have that kind of money. So anyways, like I said, first I'm going to talk about virus total for those that you don't know. But first of all, can I get a count? Raise your hand if you know what virus total is. Thank God. Anyways, try to lighten up a little bit. I was hoping that was the case. Now, how many of you know what virus total intelligence is? Awesome. Yara? One more? All right, so we're very familiar with this stuff. And so basically it's going to cover a lot of that stuff. Finding value in hunting rules and how you can take that data and make it more valuable to you with Elasticsearch and kind of feeding the virus total notification from the virus total notification API into Elasticsearch to be able to store the information and have it go somewhere else other than just into your email inbox, which isn't really the best for analyzing big data. When you're looking at maybe a few 100,000 notifications, how do you parse through that data and start to build automation on top of that and things of that nature? We're going to go through maybe when you find out about a new tactic, whether it be through a new phishing wave or you see a new blog post or you see something on some Intel forum or on Twitter, maybe they're using a new tactic that you haven't seen before. So you can go into virus total and do a retro hunt and go obtain maybe some stuff you might have missed prior to deploying those hunting Yara rules. For those of you that don't know, virus total is obviously a place where you can upload malware and get it scanned. Although I don't recommend it, personally. There's an example. I'm going to kind of blow through some of this because I didn't really exactly know what the audience would be like, so I have some very basic stuff, and I'll try to go through that as quickly as possible and still try to touch on it a little bit for those that might not know. For those of you that don't know, Virus Total Intelligence is a paid intelligence feed you can get from them. It's quite expensive, but allows you to like download samples, any samples of an uploaded virus total, and also allows you to deploy a hunting rules, which we'll get to in just a moment. This is just an example of the interface. You can, search for a hash, and it'll show you the file, and it actually has a little bit more in-depth analysis than what the public virus total will show you. It allows you, like I said, to download it or even look at the strings of the file, some of the features that aren't in the public version. Just a few examples of like what you can see, a little bit more information, like I said, the strings that you can see inside of it. Just some really simple stuff that virus total intelligence allows you to see that, like I said, the basic virus total doesn't. So what is Yara? For that, those of you who don't know, is just really a tool aimed at helping malware researchers, or even small company, in my mind, develop their own kind of AV signature, essentially, right? So what can you do with it? You can track malware families, different packers, different imports. You can, base your rules on specific strings, maybe that are hard-coded into binaries, or static indicators, potentially opcodes, different types of functions, and so on and so forth. This is a basic GrrCON rule. Basically, you can see as the meta, just a description. You can write some other stuff, like maybe you have a hash reference, or the author. You can put it in the meta, and then in the strings are actual conditions that you can write with some Boolean logic and specify, like in this case, A or B or C. So if any of those are seen in a file, it will be detected. Not all of them, just any of them, at least based on the logic. Anyways, so why is that important to virus total intelligence? Is because they have a feature that allows you to deploy hunting rules. Which is a YAR rule that they deploy. So every time a file gets uploaded to VirusTotal, it will scan it with these hunting rules and send you a notification if it matches your YAR rules, which can be incredibly powerful just based on very simple indicators. Or, one of the things I'll get to is how you can take maybe two different signatures and put the data together in Kibana and be able to visually see, maybe you have a more strict signature, and you compare it to a very less strict signature, and you can see maybe what you might be missing based on those different types of artifacts. I'll get into that, like I said, just a second. But so basically, can you give you kind of an overview? We talked about the YAR rules, and there's two different ways you can get essentially hashes from VirusTotal based on these YAR rules. One way I just talked about was the notification feed, which every file on upload will get scanned. But there's also another feature called retrohunt that allows you to scan back approximately 30 days. Not really quite. I don't have a hard date, but it's normally around I think 75 terabytes lately. Seem accurate. They obviously just don't have the capacity to allow you to scan back years, because that'd be really an insane amount of data for hundreds of companies to be querying that per second. It's insane. I'm sure it's very taxing. Luckily for us, it's pretty quick, actually. So there's two ways you can get the the MD5s essentially to feed into your ELK stack with the data. And you can, like I said, with the retrohunt, you can go back and you see a new blog post using a new VBA function, and you maybe have not been tracking that, so you can go in there and launch a retrohunt to find the ones that you'd missed in the last 30 days, and take those hashes and use the VirusTotal API and pull down all the full file reports for those hashes and feed them into VirusTotal for additional context on data that you missed, and obviously deploy the YAR hunting rule to allow you to kind of match those things. Lost my third thought. Anyways, so yeah, like I said, some about the YAR hunting rules. So yeah, I was pretty close. 76 terabytes was the one I ran. So this was based on one of the new underscore painted VBA macros. I forget actually which one it was, but basically you can see right here that I matched 3,977 documents just based on this one retrohunt. Which, to give you context to, if you don't maybe do a lot of reverse engineering, you're not doing a lot of looking at what's going on in these malicious documents, this can be really interesting to tell you hey, this execution method that you see, is it something that's being seen in the wild? At what degree, right? If you got one or two hashes back, I'd be much more concerned with a method, right? Maybe that tells you that the campaign is just starting, or that it's more of a targeted attack. But when you see 3,900, it's okay, this is obviously a bigger wave. It kind of gives you a context of how you treat that from an intelligence standpoint, is, and how you should move forward. Is this just a mass attack, or is it something that someone's specifically targeting us and using something of that level just on us, right? Anyways, so to give you some examples of how you could compare these things, so those VB macro calls I was talking about from documents, if anyone's familiar, how many have seen the ink picture one underscore painted VBA macro call on Word docs lately. And can I get anything? No one? All right. Anyways, so basically, there's some execution methods they were using. So you would take like this rule where you see the ink ink picture 1_painted and the GIF painted, and you first you'd identify that the file is a document by the file header D0CF. And so on, and then you'd also see if there is an ASCII string with either GIF_painted or ink picture 1_painted in a document. And so what I would do is, you'd deploy this rule, for example, as a more specific rule that you definitely know is malicious. And then you could take it alongside this next rule where it's actually just _painted by itself, and then you could see maybe potential ones that you're missing. And the reason I pull this distinction out is because a company like us, we have the ability to use Yara rules to block inbound attachments through email. So every time an email comes in, our engine will scan it with Yara signature, and if it matches, then it will block and remove that attachment from the users from ever getting that attachment. So obviously, you have to be a little bit more strict on those rules that you deploy, because you don't want to start blocking all of your company's emails, and you're going to get fired. And it's a good resume generating experience, as one of my upper management people would say. So what you would do is you would have a rule like this that's much more specific and that you've seen, and you've used like retro hunts to verify that there is not a huge false positive ratio with this rule, or ideally of no false positives. If you do have false positives, like you should probably go and look at why. Maybe you need to make your Yara rule a little bit stricter so you don't have to run that risk of, people being mad that you stripped their emails. So you would compare it with hits with like maybe a more generic rule in VirusTotal, and then you could compare the hashes and see what's hitting and what's not, and then maybe go see what's not hitting in VirusTotal and see what you might be missing to make your rule catch the stuff that you're missing. And then you can even open up even more, where you basically write a very wide open rule that not necessarily is going to generate all malicious documents on its own, but you can just detect a VBA file in a Word document, for example, and compare that against your, each data set up and see, maybe I have a few thousand hits with these, and then I have, double that with the _painted, and then with just macro calls in general with, additional rules, obviously, you can see that, there's, 100,000 files that have been uploaded that have macros in them, and I'm only detecting, 10,000. That could give you a really good representation of how well your more specific rules are doing based on that context. And if you don't have the additional indicators to specifically track the other ones you're missing, you can then pull those down from VirusTotal and potentially develop even more rules to help you there, as an example. Anyways, so back to this collection thing. So now we've kind of looked more at the actual rules and maybe how you can feed that into Elasticsearch. So when you pull those notifications from the API, you just feed it into Elasticsearch, and it allows you to write additional scripts that could compare all this stuff automatically for you. So literally, you just have a script running every day that's okay, I'm going to go into the VirusTotal notification index, and I'm going to pull all of my VB call hits, and then I'm going to pull all of my more specific hits and do a comparison, and then maybe run an additional tool to spit out the functions that you might not be getting, and maybe send you an email about it that you can then go and do some manual analysis to increase your detection. Anyways, so back to Elasticsearch. So basically, Elasticsearch and Kibana will allow you to visualize notification patterns. It will tell you when potentially a rule is dropped off. We've seen this in the past, where a big wave will hit, and then you'll see that the Yara hunting rule stop hitting, or it will hit less frequently. Go from hitting a few hundred hits a day to 1 or 2 hits a day. And this tells you how active that one is, and it gives you a good representation over time. When something drops off, maybe you should be looking into what they're, pivoting to use, or, what you're not detecting now that gap is there. Because obviously, if you go from 100, there's 100,000 notifications a month or whatever on, documents with macros in them, and all of a sudden you're detecting 10,000 and you're detecting 5,000, there's still going to be 100,000, like it's not like they just went away and it's gone. Like obviously they've pivoted and you need to pivot with them. Try to keep ahead of them. Just for example, just to show you, like, over time, you can see that, maybe some days are more specific, and then you can kind of maybe potentially build a pattern on that. But not typically. Normally it's just based on your rules. Like when you can obviously see this peak in the middle, we probably just deployed a new rule and started to pick up more things, and then you can see it gradually goes down afterwards, and then maybe we're deploying more rules to bring that back up. Normally, if you don't manage your rule set, you're not going to like continually see that increase in your hits. You're going to actually see a decrease in your actual more specific hits, and obviously, if you're just looking at word macros, it's going to stay pretty much the same. Anyways, so just to give you an example, you can quickly just look in your dashboard and be like, based on all of these rules, I'm seeing basically all these different, you can see the bigger half is like the more wide open rule, and then the in this right hand, can I see that? Nope. So yeah, like the pie chart, basically the Microsoft just basic macro call is this like yellow side of the pie, and then there's a VB call by name function that you can see this like blue slice, and then you can see as it goes down. So like that blue basically represents probably most of your overall macro scripts, because obviously it's representing about half of the overall macros you're seeing just based on this picture. Does that make sense? Can you see that representation? I'm not, all right. So anyways, so what you can do after this, right? Like, so you have all this stuff hitting, you're indexing all these basically JSON reports that you can pull from the API from VirusTotal, and you're putting it into Elasticsearch and into an index. So what can you do after, you have these rules? You have the rules that are detecting more specifically and the ones that are detecting less specifically, and how do you automate that so you don't have to do too much manual work? Because, who wants to work? We all want to like go and have beer, have a good time. We want to stop the bad guys though. So we can feed it into like a Cuckoo or a different paid commercial sandbox. All right. And then you can automate maybe IOC collection from the Cuckoo API and deploy it to like in our case, TAP, or in someone else's case, whatever IDS rules that you have, or however you're detecting like domains, IPs, or anything else that can show up in a a Cuckoo report that you could use for deployment. And then you can automate notifications as well. So like I was talking about earlier, you could automate a notification to show you all of the BBA functions in the documents that you're not hitting on with the more specific rules, but you're hitting on with the more like generic macro rules. And obviously some of those will just be straight like benign. There is cases where that does happen, but it's not as frequent. So when you automate the use of these collection scripts, you can greatly increase your detection, kind of like net, and then have to automate this stuff and not have to like do all this stuff manually, and kind of like essentially create your own intel instead of relying on another vendor to generate the stuff for you. You can do it all yourself for a relatively like easy cost to you. For those of you who don't know, there is a rule list out there, the Yara Signature Exchange. If you can get on it, I would recommend it. It's basically a community list that provides Yara signatures, and people collaboratively work on them, so you can maybe learn from some other people, deploy their rules, and also track the campaigns that they're tracking as well. And with that, you can actually get a free into VirusTotal intelligence. However, it's a little bit limited on what you can do with it. Anyways, to kind of like bring this around and like, so what can we do? What is a script that I don't have to write to automate, the collection of some of these IOCs? I'm going to talk to you just about one. It's called Viper Monkey. How many people have heard of Viper Monkey? It came out a little bit recently. So it's just basically like a VBA macro parser. You can run it against malicious Word documents, and it will try to deobfuscate the code that is being obfuscated. So for an example, he has on his website, as an example for using his script, this Python vmonkey py against this old 2009 Word document. And you can see in this first picture that down here, the private declare function URL download a, like, and then there's just a bunch of like gibberish after that in some of those calls. And what it would do is it goes through and it starts to detect some of the code, and then it will basically record some of the actions that it's detecting, like the downloaded URL, what file is being written out, and what commands might be potentially being executed after it tries to deobfuscate the malicious Word document. Now, this isn't a perfect script, but it definitely can work on a good, decent ratio of these malicious Word documents we've been seeing. Yeah, basically you could just have this run against all the stuff you're not seeing, and maybe spit it into another Elasticsearch index, and then be able to look at that information and see, like I said, maybe some of the stuff that you're not seeing, or even deploy URLs and IPs that you are seeing in these Word documents. It's just one of the many examples. I could probably talk for like 8 hours up here about all the different possibilities of what you could do with this. But so I had a demo, but obviously I'm out of time, so it's not really too bad because demos kind of can go terribly. Basically, just to recap, it was just a basic overview of how to, just one use case of many that you can use VirusTotal Intelligence. Malicious Word documents is just the one I used. There are plenty more use cases, and don't be afraid to go in there and start writing very open rules. There's nothing wrong with flagging in VirusTotal with a very open rule. It's just a learning mechanism. Now, obviously, there is something wrong when you start flagging out a lot of Word documents coming in and you're blocking that. But maybe you have the ability to alert on documents coming in, and you can build a detection ratio based on what kind of is in the wild, even though VirusTotal is a little bit more of a kind of more of a biased set of data, because people submitting things to VirusTotal tend to have the intention that it's already malicious, and it's going to be a little bit more, it's obviously way more malicious than what you'll see in just a generic wild. Anyways, I'm out of time, so we will end there. Does anyone have any questions? So we use it to detect, like I said, those pivots in those Word campaigns, and to deploy automated IOCs to our alerting systems. So like if we're seeing, a new Word doc campaign we haven't seen before, we'll see like how we can automate the collection, automate the collection of those indicators from it. So if they're using like a static value or something we can base a pattern off of, and we go through and extract out like the IPs and the domains, or maybe a value that the Word document is using to execute, we will then deploy that, to block those incoming Word documents before they get to, the end user. Or to deploy, if you don't have that capability, maybe there's not something you can trigger on in the document, you could write another script that just goes through and like pulls out those indicators, those IPs, and then gives you alerts if you see those IPs or indicators get hit. Obviously, it takes a little bit more fine-tuning and stuff, and then one more? Yeah, that's fine. All right. Thanks for coming. Hopefully that was enjoyable for you guys, and you learned something, and it wasn't, total waste of your time.